Okay, students, Assalamu alaikum.
वालेकुम अस्सलाम।
Okay, so last time we were talking about mass and weight. We discussed some problems related to the properties of mass and weight, the difference between mass and weight, and we also solved some questions related to the formula of the weight and the concept, or we can say that the difference between mass and weight, right? And after that, in the same chapter, we are also having a topic of density, mass, weight, volume, density. So volume, today we are talking about, we are going to discuss about the concept of volume, the formula related to volume and density, right? So our main focus is on density, because from this chapter, density is more important as compared to mass and weight, because mass and weight is generally a common term, or we can say that in our lower secondary classes we already discussed many about mass and weight. So density is a detailed topic in this chapter as compared to mass and weight. So this topic is much more important than mass and weight. So first of all, if we talk about the density, so what is the basic definition of the density? So first of all, we need to know about the basic concept of density, and the basic definition of the density is mass per unit volume of a material. So the mass per unit volume of a material. And what is the concept of mass per unit volume of a material? Let's suppose if we are having two different type of matter. Let's suppose one we having a cotton and second one is a stone. And let's suppose we consider a cotton like a in form of a cloud. We are having a cotton, and the second component is of stones. We are having some marbles, or we can say that. So if we consider these two objects, one is the cotton and second one is the marble, and we need to fit the cotton and we need to fit the marble individually in separate boxes, right? We are having a box in which we need to fit the cotton and which you need to fill with the marbles or stones, right? So we are having two boxes, and let's suppose both boxes are identical. It means their size, their volume is similar, or we can say that both are having same volume. So boxes or cubes are identical. So let's suppose if we start filling the cotton and the marbles in the box. So after filling the cotton and the marble in the box individually, so what will happen next? Which box will be heavier? If we want to compare that, which box is heavy and which box is the light one. So which box will be heavier? The box containing
Marble.
marbles. Yes. So the box containing marbles will be much heavier, right? And what is the reason? Because we are taking the same boxes, the volume of the boxes are same. हमने दोनों boxes का volume same लिया, लेकिन एक में marble को fill किया, एक में cotton को fill किया. लेकिन marble वाला box जो था वो heavy हो गया as compared to the box of the cotton. So reason क्या है? जबकि दोनों boxes का volume same था. Identical का meaning ये हुआ कि दोनों का volume same था. Okay, according to the definition of density, the mass per unit volume of a material is called density, right? So basically हमने mass तो fill किया, लेकिन हमें mass पता है कि mass is a quantity of a matter in a body. So when we are talking about the quantity of a matter in a body, so we know that marbles are much more solid and molecules are much more tightly packed as compared to the cotton, right? And you know that cotton is a light type material as compared to the marble. Molecules are not much tightly packed together in cotton as compared to the marble, right? सो डेंसिटी का कॉन्सेप्ट हम इसको इस तरह से एक्सप्लेन करते हैं कि व्हेन यू आर गोइंग टू फिल अप एनी स्पेसिफिक वॉल्यूम विद different masses, so that combined quantity will give you the concept of density, right? Let's suppose if we take the example of a stone and a ship. If we consider another example, a stone and a ship. So what happen if we drop a stone, and if we drop a if we drop a stone in the sea water, and if we consider a ship in a sea water, so which object, or which we can say that the matter will float, or which quantity will sink, stone or ship?
Ship will float and stone
Ye-
will not float.
because we know that ship will float and stone will sink, right? This is our journal observation of daily life, right? But what is the reason that stone is a very, we can say that very small or tiny in size as compared to the size of the ship? Then why ship floats and why stone sinks? Any idea? So
Because
basically,
the ship
Mhm,
because the ship is very huge and big
mhm.
in a size, that's why ship will float, and stone is very tiny object, that's why it will not float.
Okay, very good. So basically, the reason behind this, the flotation of the ship and the sink of the stone in the sea water, is the concept of density. You observe that in the ship, there is a very large space which is empty, and there was no use of that space in the ship, right? So we increase the volume. Let's suppose if we consider the formula for the density. So the formula for the density is the formula for the density, the symbol for the density. So the symbol for the density is symbol of rho, like inclined P, and density is equals to mass over volume. So this is the formula for density, right? This symbol represents the density. And if we want to write in the symbols, so in symbols, we can write the formula like this. The density is equals to mass over volume. Okay, so always remember one thing while talking about the quantities, while talking about the formula in physics. This is our first formula, or sorry, second formula. First one we discuss about weight, W equals to mg. This is the second formula, and this formula is very much important. And why the formula is important? Because the reason behind the flotation of the ship and the reason behind the stone sink in the seawater is density. And why it happens? Let's suppose if we consider the stone. So if we talk about the first example, so first example is related to the stone. So if we consider a stone, so let's suppose there is some type, or we can consider a type of shape for a stone over here. And let's suppose it is filled with completely with mass, right? So basically, according to the definition of density, we know that mass per acting per unit volume is known as density. So let's suppose this is our stone, and this stone contains some mass, and that mass is divided into specific volume, right? जिस तरह से हमने एग्जाम्पल कंसिडर की थी कॉटन और मार्बल्स की कि हमने उन्हें बॉक्स में फिल किया था, तो बॉक्स का एक फिक्स वॉल्यूम था। इसी तरह से जो स्टोन की शेप है, सो दैट शेप डिफाइंस द वॉल्यूम ऑफ ए स्टोन, राइट? So in simple words, if we consider the shape of a stone, so that shape defines the volume of a stone, right? Because volume gives you the concept of length, breadth, and height. The three-dimensional concept for any material, right? Any confusion?
No, sir.
Okay, so basically, stone is made up of a solid material, and that solid material is divided into the given shape, or in a scientific term, we can say that into the given volume, right? So this is the volume, and we can say that this is the shape in which the total mass of the stone is divided. Okay, now let's consider the second example, and the second example is of ship. So if we consider the example of a ship, so for ship, we need to consider a huge shape as compared to the stone. So let's suppose if we are talking about a type of a ship or a boat, we can say that, and we are having a sea water under it. Okay, now you know that the size of the ship is very much heavier as compared to the size of the stone, and also the mass of the stone. So the mass of the ship is divided into its given volume. So this represents you the shape of the ship or the boat. And again, shape means the volume. Volume is the product of length, breadth, and height. So now you know that if we compare both stone and ship, so which example contains the largest volume, a ship or a stone? अगर हम दोनों को कंपेयर करते तो हमें किसका वॉल्यूम ग्रेटर मिलेगा, शिप का या स्टोन का?
A ship.
Ship, because we know that the size of the ship is very much greater as compared to the stone. So in simple words, we can say that the volume of the ship is greater than the stone, right? So now let's compare, or let's try to connect it with the formula, because we need to solve the numerical terms. So in the sense of formula, we can say that we are having density equals to mass divided by volume. So first, if we consider these two terms, density and mass. So density is directly proportional to mass. This symbol, the symbol of alpha, means directly proportional. Directly proportional. These are new terms. That's why I am taking it very slow. So once you got the concept, then after that you will easily got the whole concepts in other formula. So if you observe that there is an alpha type sign like this, and this sign represents the directly proportional. Directly proportional means if we increase the mass, so density will automatically increase, right? Let's suppose if we increase the mass of an object, so the density of the object will automatically increase, right? If we compare density only with the mass, right? We are not talking about volume right now. Okay? Any confusion?
No, sir.
Okay. Now, if we consider the second term, what is the second term? The volume. So if we compare it, the volume, so volume is in denominator. So we need to write 1 over V. So this 1 over V means inversely proportional, right? This is inversely proportional. Got it? If some quantity, or if any type of quantity is written in numerator, so that is directly proportional. And if a quantity is written in denominator, so that is known as inversely proportional, right? Any confusion? And what is the sense of inversely proportional? Any idea? In directly proportional, we know that if one quantity increase, so second quantity automatically increase. I will write the definition for these terms too, so that will make easier for you to memorize it. So we are having a concept of directly proportional and inversely proportional. So what is the concept of directly proportional? If we increase a magnitude of one quantity, so the magnitude of second quantity will also increase, right? Any confusion? And if we consider another
No,
term, inversely proportional, these terms are very much common. And whenever we are talking about any scientific formula, so we need to know about these concepts because these concepts will help you to identify that how quantities are going to interlink with each other. So the second definition is if we increase the magnitude of one quantity, any idea what will happen?
no, sir.
So that is inversely proportional. Inversely proportional means so the magnitude of other quantity will decrease. If we increase the quantity magnitude of one quantity, so the quantity of, or we can say that the magnitude of second physical quantity will automatically decrease, right? So if we increase the magnitude of one quantity, so the magnitude of second quantity will decrease, right? Let's suppose if we compare the currency, or if we want to know about the comparison between the currency of the dollar and Pakistani rupee, so you know that if the dollar increases, so the value of the Pakistani rupee will automatically decrease. So that is inversely proportional, right? One quantity is increasing, second quantity is decreasing, right? So when we are writing inversely proportional for the second term over here, so actually it means that if we increase the volume, so the density will decrease, right? So let's write it down so that will easy for you to memorize. So the very first thing is density is directly proportional to the mass. So we may write it as density will increase with increase in the mass of a body. So we know that density is directly proportional to the mass. So if we increase the mass of a body, so density will automatically increase with the increase in mass of a body, right? And if we talk about the second quantity, that is inversely proportional, and that inversely proportional is volume. So we know that density is inversely proportional to volume, which means that density will decrease with increase in the volume, the volume of a body. Any confusion? Got the concept of directly proportional and inversely proportional?
Yes, sir, no confusion. But these two quantities have their formulas or not?
Actually, when we are talking about density, so this is the formula for density, right? You need to memorize this formula. And why I am writing this inversely and directly? Because when we are talking about the difference between ship and stone, so you know that which object has greatest volume, ship or stone? Ship, right? So we know that if we increase the volume, and we know that the volume of the ship is greater as compared to the stone. So if we increase the volume of an object, so we write it as that density will decrease with increase in the volume of a body. So if we increase the volume of any object just like the volume of a ship, so we know that density will decrease. And you know that object with less density will float on the surface, and object with greater density will sink into the water surface, right? ठीक है, तो अगर आपकी डेंसिटी जो होगी वो वाटर जो सी वाटर है उससे ज्यादा होगी, ठीक है, तो आप डेंस मटेरियल होगे, तो आप सिंक करोगे वाटर सरफेस में। और अगर आपकी डेंसिटी लेस होगी उस सी वाटर से, तो आपकी डेंसिटी कम होगी, आप लेस डेंस मटेरियल कहलाओगे, और आप वाटर सरफेस के ऊपर फ्लोट करोगे। क्लियर हो गया यहाँ तक कॉन्सेप्ट कि शिप क्यों फ्लोट करती है और स्टोन क्यों सिंक करता है? एनी कंफ्यूजन?
No, sir.
ठीक है, आप चैट में भी अगर लिखना चाहो तो लिख दो ताकि मुझे एक क्लियर कॉन्सेप्ट हो जाए कि किसी को कोई कंफ्यूजन नहीं है। अगर कहीं कंफ्यूजन है तो आप मेंशन कर देना, मैं उसे रिपीट कर दूंगा। ठीक है, क्योंकि ये छोटे छोटे बेसिक कॉन्सेप्ट हैं स्टार्ट में। सो इफ यू आर नॉट गेटिंग द कॉन्सेप्ट सो दैट विल बिकम डिफिकल्ट व्हाइल सॉल्विंग द क्वेश्चन। ठीक है, तो यहाँ तक कोई कंफ्यूजन नहीं है, क्लियर हो गया कॉन्सेप्ट। अब कोई पूछे कि व्हाई द शिप फ्लोट्स ऑन द वाटर सरफेस एंड व्हाई स्टोन sinks into the water surface, so you know the concept that ship is less dense material as compared to the sea water, that's why it is floating. And stone is a dense material as compared to the ship, that's why stone sinks into the water, right? Because we know that the volume decrease, so density will increase, right? Okay, and let's talk about the SI unit. So what will be the SI unit of density? Okay, there is an interesting thing. If you don't know, or let's suppose in exam you are not getting the exact formula, or sorry, the exact SI unit, that what is the SI unit for the quantity which you are writing in your question. So you don't need to worry. Let's suppose if you know the basic formula, this is the formula for density, mass over volume, right? So what is the SI unit for mass? What is
Um, uh, Newton?
last time we talk about
No, no,
the
no. Wait. Wait.
uh, you need to write the SI unit. There are two different things. One is symbol and one is the SI unit. So symbol is M and the SI unit for mass is kg or gram?
Uh, kg.
Kg. So basically kg is the SI unit for mass, and what will be the SI unit for volume?
Volume.
because volume is a product of length, breadth, height. So we are having three length. So when we multiply three lengths, so we will get the answer meter cube, right? So always remember that the SI unit for volume is meter cube. So combining these terms, you will get the SI unit of density, that is kilogram slash meter cube, that is kilogram per meter cube, right? Kg per meter cube. Okay. Any confusion?
No, sir.
Okay. So this is the concept, or we can say that the basic concept of density, that what is density, what is the formula of density, what is the SI unit of density, and how we use the formula for density to find out the difference between a dense material and a less dense material, right?